All right, let's see, back to the Zoom. All right, so thank you everyone for coming in. Please take a seat. So today we are joined by Andreas Clay, who's going to be giving a guest lecture. So Andreas has been a web browser developer for a very long time, working on AE, working at Nokia, working at Apple on the Conqueror and then WebKit web browsers. Is that right, Andreas?
Sounds about right.
Cool. So he'll be talking about his latest project, which is Ladybird. It's a from-scratch browser development project. I believe the plan is to have Andreas talk to us for a bit about Ladybird and then have some time for Q&A at the end as well. So hopefully we'll be treated to some information about Ladybird, maybe some actual development, and then questions from all y'all. There's a conference room mic set up by Mike right there. So we'll have that muted while kind of Andreas is doing the talk on his end, just because there's, people are eating or there's murmuring or whatever. But for Q&A, we'll open it back up so that anyone can ask questions. So I hope that's good. And Andreas, please take it away.
Sure. Thank you. And hello to everybody. It is nice to be here. Today, I'm going to talk to you a little bit about Ladybird, which is a truly independent web browser that we are working on. And I also want to give you a demo of real-life browser engineering. So I'm going to show you the kind of thing I do every day and fix a bug, basically. And then after that, we will have time for questions and answers and whatever else. So that's kind of the setup I hope to do. But we're going to start by just talking about Ladybird. So, oh, it works. Okay, so I am the project founder. And as Pavel mentioned, I've worked on browsers for most of my career from the HTML project back in 2005 when I was maybe your age. I'm not sure exactly how old you all are, but when I was a young man, I used to work on the KDE browser. And then I worked at Nokia, Apple. And then nowadays, I am working on Ladybird, and I'm also working on Serenity OS, which is sort of an operating system project where Ladybird started before it spun off to become a cross-platform project. Anyway, let me talk about the browser market in 2024. So a lot of people ask me, why would you ever want to build a new browser? And this is my attempt at answering that question. So all of the major browsers today really are in one or three of these circles, no, one or two, where either they use the engine from Google, so they use the Chromium engine. This is true for Brave, Edge, Arc, and Chrome, of course. But the lesser known thing, perhaps, is that the right ring exists as well, where browsers are funded by Google. And for Safari and Firefox, the way that works is that Google pays them in order to be the default search engine in those browsers. So they have these 9-figure deals with Google. And although this wasn't publicly known when I worked at Apple, everybody kind of knew anyway that Apple had absolutely no need to make money with Safari because Google was funding the whole department. But I think there were some court documents that came out a while ago where the actual figures finally were revealed. But anyway, this is how the browser market looks today. So it's either the engine or money from Google. And I think it would be lovely to have something outside of this paradigm. And that is what I want to achieve with Ladybird. So it's just totally outside of this whole thing. It is a truly independent web browser, which means it's a completely new engine just based on web standards. It's from scratch, so we don't share code with any other engine or any project. And it is extremely from scratch. So not only do we have our own HTML, JavaScript, CSS stuff, but we also implement all the image formats like JPEG, PNG, GIF, whatever, video formats, audio formats. We do networking. We have our own HTTPS and encryption stack, fonts, everything. We are extremely full stack, and that's the way we like it. It is open source, and we develop in the open. So as you've you've already noticed you can download it and participate in development if you like. And we are entirely funded by donations and sponsorships. So I've been working on this full time for the last 3 years because I have Patreon and GitHub where people sponsor me to do this stuff. And we have never taken any kind of strings attached donation. And finally, we also have no ambitions to monetize users or have any kind of default search deal. So even if Google were to offer me $5 billion to put a Google search box in there by default, I'm just going to say no. And I'm sure that will be painful when I do it, but we'll see. Anyway, where is Ladybird today? So our foundations are pretty strong, I would say. Those of you who have tested Ladybird have seen that it can handle basic HTML pretty okay. But once you throw some modern content at it, it does start to show show where things are lacking. We are still catching up to the very latest in CSS. Those of you who follow web development would find a lot of the new stuff missing, like we don't have CSS nesting or has selectors or fancy effects. And our vector graphics are so-so, the partial SVG support, but many websites do work in Ladybird. They are just buggy and slow in particular. So we have a ton of room for improvement in performance, but it's something that we've kind of been putting on the back burner as we just try to get more websites to work. So compatibility first, performance later has been our way of thinking about it. To give you an idea of our maturity, here are some screenshots of Ladybird in action. So we've got GitHub and a cat account on Twitter. And if you look, you'll notice that I'm logged into these sites in the screenshots. So we're not just looking at a public page, but we've actually like interacted with the web app and logged in and done all that stuff. So it is pretty competent at a lot of this basic web app stuff. A couple more screenshots. But it's like one of those pictures, like the longer you stare, the more problems you notice. So before you notice too many problems, let's just move on. So who's working on this today? It's three full-time engineers, including myself. And we also have a huge international community of volunteers. As I mentioned, it's part of the operating system project, Serenity OS, which has over 1,000 contributors at this point, and about 280 or so, as of last time I counted, have worked specifically on Ladybird. So we also have like another 700 people who only ever worked on kernels or device drivers or whatever, but never touched a line of code in the browser. So it's all in one project. That's why it gets a little hard to measure sometimes. And our main community hub is on Discord, so it is very, very accessible. The URL is on top of the screen here for anybody who wants to come join us and chat in the browser channel. And this is where we hang out every day. We collaborate on stuff that we're working on. Again, if you look, you'll notice that this is Discord in Ladybird, which is something that we've been putting a bunch of effort into getting that working as well. And we were really happy with when we got it to run. And to give you an idea of sort of project popularity over time, this is the GitHub stars metric. I know that it's a silly metric, but it's like the best popularity metric I could think of. And I like this graph because it shows that we never had like a big viral moment where tons of people discovered us. Instead, it's just been slow and steady over time. People kind of every day somebody new discovers what we're doing and they like it and they come join us. And I'm a big fan of that. And I mentioned donations and sponsorships, so I wanted to just give a little bit of insight in that. Last year, I got $310,000 in donations, one from Shopify and two from two private donors who didn't want to reveal their identities. But they all gave 100,000 each. And then I also got a smaller one from a German company called Ohne Makler. And these are all just donations from companies and individuals who wanted us to make progress on this. And I myself also received these personal sponsorships on Patreon and GitHub. So that's this is how I was able to hire some additional employees last year. It's been just me full time for a long time, but in the last 6 months, I've had 2 employees. And what is next for Ladybird? We're just going to continue working on it, implementing missing features, filling in the gaps everywhere. And we want to radically improve performance as well. It is very slow. When I show you it running, you'll see how slow it is. And my ambition is that we'll have some kind of usable beta on Linux and Mac OS in 2 to 3 years, something that doesn't necessarily work with everything, but that you can run for day-to-day browsing and report bugs to us when it doesn't work. Or maybe fix them yourself. That would be ideal. Anyway, that concludes my little presentation about Ladybird. But now I would like to show you working on Ladybird, what that looks like. So I thought the most interesting thing to show you would be your own school website. I hope this is the right website. I don't have the wrong school, but that's the right one. Okay, I'm seeing a thumb up. Good. Yeah. So as you can see here, it's taking a while to load, but it is loading. We just have to be patient. So a lot of the issues here with the loading performance are just slow networking. We're not scheduling loads in a smart way. Like maybe we're loading a bunch of images before we load the CSS. Stupid stuff like that we can do better. We just haven't worked on yet. But I think it has loaded now. And we can see that the website is here. It's a little, got some holes. But generally, you can recognize it, I hope. But there is a big hole up top here, and there's also supposed to be this carousel of images. If I actually load this in Firefox, you'll see, well, you'll see how fast it loads for one thing. Wow, look at it go. And you'll also see these images here, which are missing for us. We just have the one gentleman. And here there's all kinds of images, and the gentleman is just one of them. So today, we are going to investigate why this happens. And there are, well, I had a longer version of this investigation, but then I realized it would take way too long to do in a live demo. But we can just look in our debug console here, and we see a bunch of fix me's that we need to implement element outer HTML. So that is pretty helpful. So in Ladybird, a lot of APIs are just not implemented yet, because we kind of implement stuff when we think of it or when some website needs it. We haven't been approaching this by like taking each spec and just starting at the top and implementing everything one thing at a time. What we tend to do is, let's get this website working. What does it need? Okay, let's do all those things and then move on to another website. So this is happening once again here, that this website kind of works, but what does it need? Probably outer HTML. So if you are not familiar, outer HTML, let me make a little test page for it. It is an API that serializes HTML. It's very similar to inner HTML. Hello, students, let's say. And let's open that in Firefox. So if I were to use the console here and say document body outer HTML, I get a serialization of the whole body element. And actually, it shows it a little fixed up because I didn't type out the whole thing because I was lazy. So let me do that, make it a little nicer. All right. And it's very similar to inner HTML, which shows you the, well, the inner part, so excluding the body element. But if you do the same thing in Ladybird, we will see that, well, let's test it out. Document body outer HTML. It is an empty string. And we get this fix me that we need to implement it. So let's look into doing that. So we'll just go and look at the outer HTML function in our element class. We can see that this is where this debug statement is coming from. And I don't know why I have a loading indicator in the middle of my screen here, but hopefully it's not going to do anything annoying. Um, and in our engine, we also like to link to this relevant spec text around all of our functions that implement some spec mechanism. So this allows us to very quickly go and visit that spec so we can see what it is that we need to do. And we can read about outer HTML here. It says that the outer HTML attribute represents the markup of the element and its contents. On getting, which means when we're reading from the outer HTML property, we should return the result of invoking the fragment serializing algorithm on a fictional node whose only child is the context object. And then some little details. But the interesting thing here is that they sort of describe what you need to achieve, but they describe it in terms of a fictional node. So they kind of want you to imagine that there is a fictional node, and then there is this element inside of it, and then, well, whatever is inside the element. And this loading indicator is going to drive me crazy. So let me just restart my IDE. Clion. But yeah, so the spec kind of tells you to imagine a DOM or a document tree where you have an imaginary parent so that you can serialize that imaginary parent with inner HTML. That's kind of what they're getting at. But very often the spec, just because the spec says to do something a certain way, doesn't mean that that's the most efficient way or smartest way to do it. And I think in this case, we had kind of the same problem, that we could construct an imaginary parent and set that whole thing up and then serialize that, but it would be really clunky. So what we want to do instead is maybe just see what inner HTML does here. And we can see that it calls serialize fragment, passing in some thing. And we can just kind of do what that thing does, but we will give it an extra parameter. So we'll say like, well, just to make this simple, I just pass true. And then we will add a Boolean parameter to this guy. So serialize fragment, we'll add a bool outer HTML, which we will default to false so that we don't have to update any of the existing callers of this API. But then once we have that, then we can then change the behavior of serialized fragment internally in case you're calling it from outer HTML. And that means we also have to update here, outer HTML. And what does this function do? Again, we can go look at the spec link, but it's really small, so we can also just look at what it does. Essentially, if the context document is an HTML document, then we should do an HTML serialization of the node. And the case we care about is always going to be HTML. So really, we know that we're going to be calling the parser serialized HTML fragment. And here, I'm just going to pass along the outer HTML flag to this API. And then we will add that flag to this API as well, defaulting it to false, just so we don't break any existing clients of the API. And then serialize HTML fragment. Okay, so this is the workhorse function of serialization. This is the thing that takes an arbitrary DOM node and just spits out a string. I don't know how familiar you all are with C++, but it's what most browsers are written in, so it is a good language to learn for this. So I'm just going to keep on trucking here. So we're adding the outer HTML flag. And what are we going to do with this thing? Well, we need to understand what this function does, right? So conceptually, we know that it takes a DOM node and returns back a string serialization of that DOM node. And that serialization happens recursively because a DOM node could have any kind of hierarchy under it, right? It could have all kinds of children with children of their own. So this is a recursive function. But if we look at what it really does, it creates a empty string builder, which is what we serialize into. And then it will iterate over the children of this node in tree order. And just like depending on what kind of child it is, it will perhaps serialize an element with all of its attributes, or serialize a piece of text maybe further down if it's a text child, or maybe it's a comment. HTML comment. You don't see those very often, but they exist. But in our case, what we really want to achieve is we want to do this kind of element serialization on the node that we're being asked to serialize in outer HTML mode. So we need to sort of take the behavior for element children and just yoink it up so we can apply it to the parent as well, if that makes sense. Um, this is all pretty typical browser work. Unfortunately, outer HTML is not spec'd. Like the specification of serialization doesn't take into account outer HTML, so they just say, oh, just imagine that it's like this, and then you deal with it. If it had been spec'd out how to handle it, we would probably have implemented it the way the spec tells us to. But now, because the spec says just imagine, we have more freedom to do whatever we like to achieve the result. So what I'm going to do is I'm just going to take this logic here that serializes an element and yoink it out. Put it in a helper. So serialize element. And then we will put that up here so that we can use it. And we will just make a local function object that takes a DOM element. Okay. So we have factored it out into a helper. Very nice. But how do we want to use this? Well, when you're calling in here in outer HTML mode, we want to serialize element on the node that we're calling with, right? And in order to do that, we probably want to do that before doing anything else in this function. So we should really be moving this up to the top so that it happens before we start doing anything else. So we'll just take that helper function, put it at the top, maybe here. Okay. And then the very first thing we do is going to be, if we are in outer HTML mode, then we will serialize an element, the current node, and then we will just return builder to string without validation. Yes. So what we're doing now is that in outer HTML mode, we just take the element that you're passing in and serialize that using this logic, which will call itself recursively if the element passed in has any kind of children. I hope that makes sense. And let's build this. And we'll see how it comes out. Well, sometimes linking takes a while. But I guess while it links, I can talk just briefly about our coding style that we have in Ladybird. You'll notice a lot of comments. All of these comments are copy pasted from the spec. We are very, very aggressive about just putting lots and lots of spec text as comments in our code because it just makes it so much easier to read the code and to review changes to it if the specification is literally quoted everywhere. It also helps a lot for anybody who's familiar with the spec because when they come and look at our code, they can immediately recognize everything because we use the same names as the spec. We paste the spec everywhere, and we try to follow the same sort of architecture as the spec uses as much as possible. Okay, so let's open that thing again, and then we will test out this new version of the API. All right. So now it includes the containing body element here as well. But if I were to call inner HTML, then it's only the HTML inside of the body. So that means that we have implemented outer HTML. It's entirely possible that there's some edge case that I'm not thinking about right now, but in the interest of moving fast, I thought we could just push ahead. So let's see now how this affects your university website. And again, the unimpressive performance. So the spam about fix me outer HTML is gone at least. And if we scroll down, we can see that it now presents the images as you expect. So we didn't learn exactly how it was using outer HTML, but just by implementing a missing API, the website just starts behaving more properly. And this is 90% of the time how things work out. You don't really have to get to the bottom of why things are broken. The moment you know which API is missing, it's often just a matter of implementing that API, and then you'll make progress. So then the next thing I would do if I am a good boy, which I'm going to be today, is I need to write a unit test so that we can prove that this thing works and we also avoid regressing it in the future. And we have a tests directory here. We have all kinds of tests. This is going to be a text test because it's not layout dependent. And I'll put it in the HTML directory and I will call it outer HTML. And then I have to write a little bit of boilerplate here just to include my testing framework. But essentially, we are just going to check that we can serialize something. So we'll put a div here. We'll call it foo. And we will put some hello students markup in here. And then we will try to serialize that. So actually, fun fact, you don't have to fetch those kind of things. If you have an ID, you can just use it like this. So foo.outer HTML, we will print that. And actually, maybe we will print outer HTML colon. And let's also do inner HTML just for completeness. And then I will generate a expectation file for the test so that we know what it's supposed to look like. So it generated this output. So this is just our test runner loads the page, executes all the scripts, and then dumps out the text on the page. So this is what we get. And it is what I would expect. It has the div for outer HTML with the B inside of it and just the B for inner HTML. And then next steps would be to package this up into a commit, write a nice commit message, open a pull request, and let somebody review it. But this is essentially the workflow of fixing a random website bug. And I'm really glad that your university website had such an obvious visual bug that I could fix so easily because it makes for a fine demo. But that is essentially that demo. So I think this is the part where I don't have a plan anymore. And I would love to take questions and talk with you all.
All right, so can we give a round of applause for our presenter?
Thank you.
Was while we were doing that, so that's great. I think we should open it up to questions. There's a lot of people, so maybe raise your hand if you have a question. And Andreas, I don't know how much time you have, but we'll keep you busy until you have to run.
Sure. I have infinity time.
What is so compelling about making a browser that is untouched by Google, even if it's just for finding the default search engine?
What's so compelling about it? I think so many things, but at the core, I think it would be nice if people could use the internet without having to go through an advertising company. It feels like the incentives are so strangely not aligned with the user, and nobody is really trying to pull away from the current paradigm. Instead, in fact, people are consolidating on Google, the Google engine. Like just in the recent couple of years, Microsoft gave up on their engine, Opera gave up on their engine, and people are kind of, nobody wants to build browser engines anymore. They're just like, oh, let's just use Google's engine. It works fine. And I think, to me, there's something very compelling about just stepping away from that and building a fresh browser engine that doesn't have to answer to whatever Google wants, and they have no influence over it. Not everybody may agree with that, and I think that's a good thing because browser engine diversity is a good thing. And these are ostensibly open standards that we're implementing, right? But if there's only one implementation that people care about, which is kind of where things are headed with Google, then are they really open standards if there's only one implementation? So I think there are many sides to it, but those are kind of the main things I like. And then also it's a lot of fun to build a new implementation. I'll give you that.
Um, what helped you like move to like supporting yourself on this project?
Oh shoot, I could not really hear that very well.
I'll repeat questions if you can't hear them. So Zane asked, what helped you move to self-supporting your work on Ladybird when you were like first trying to do
Self-supporting in the sense of getting sponsorships and donors. Was that a yes or no?
it? That was a yes.
Oh, okay. Right. So I've been doing YouTube for a very long time and less recently. But when I first started out, I did the first 6 months by myself in a house that I rented. But then I came back to Civilization and started making YouTube videos. And I would just upload, 4 or 5 times a week, screencasts of me working on this stuff. And in the beginning, it was the operating system stuff, and but it became more and more browser oriented as the browser was added to the operating system. And the YouTube channel was really like the main way that I introduced new people to the project. And I'm not exactly sure how people found it. I think in large, I have to thank the YouTube algorithm for much of it, and word of mouth. But yeah, that was like really how I was able to build an audience around what I was doing and attract people to work on it as well. And it's been a really interesting, a lot of interesting effects of having a YouTube channel about programming because the people who joined the project, they've often watched me working on this stuff for hundreds of hours sometimes. Like I have over 1,000 videos on YouTube of me working on the system or talking about it. So people have like a really good idea of how it works and what I'm trying to achieve with it. And it's very different from any other project I've worked on in the past, where you kind of have to introduce people from scratch every time. And yeah, the YouTube channel also allowed me to, I guess, build up a community of sponsors and donors who liked what I was doing and just wanted to support it.
Okay.
Speaking of your YouTube channel, the most popular video that you have up is a tribute to Terry Davis.
Right.
Elaborate on how he's influenced you or what he means to you.
Well, I think Terry Davis is a tragic character, but he had this idea that you can totally build an entire world for yourself in the computer. And I really like that. And I've messed around with Temple OS a bunch. If anybody's not familiar, Terry Davis is the author of Temple OS. It's a strange operating system with kind of religious under and overtones. Um, but I liked him because he was all about that the simple computers that he had in the 80s, and I kind of grew up around those computers as well, where that would boot into a basic interpreter, and somewhere along the way we lost that type of computer where it's now like so many steps involved before you can program a new computer. When I was a kid, like you would press the power button and then you could program the computer. And I think Terry, um, rest in peace, had this desire to sort of recreate that feeling. And his operating system ended up being very strange, but I really sympathize with what he was trying to achieve with it. And um, my operating system project, much like Terry's, was also trying to capture a kind of computing that I grew up with, although slightly different because the computing I did in my formative years was I was borrowing my parents' office computers. So I grew up with like Windows 95 and Microsoft Office, and I just like sit and doodle in PowerPoint. And I thought that was awesome. So I wanted to recreate that kind of software for myself and build an environment. And that's kind of what Serenity OS is. It's a recreation of the 90s office vibe, but with modern tools. And yeah, that video tribute to Terry Davis has done really well because Terry has a cult following. So I'm glad that they seem to appreciate it.
Do you plan to ever use or incorporate Yacht into Ladybird, or are you planning to only keep that in Serenity OS's kernel itself?
That's a good question. So Yacht is a programming language that I started working on in 2 years ago now, I guess, together with one of the Rust core team members. We wanted to see if we could build a memory safe language that was far more ergonomic than Rust is, that would allow us to program the way we like to program in our project. And it still remains to be integrated in any kind of Serenity or Ladybird project. And as time keeps ticking, we're kind of losing interest in working on it collectively, I think. And it was a fun experiment, but the reality that we have to face is that it's sitting there, but nobody's touching it. But it's every now and then, like somebody comes along and works hardcore on it for 2 weeks. So I wouldn't say it's dead, but it's suspicious.
I noticed on the GitHub repo that you're using the BSD license, and I was wondering, like, was there like a specific decision to do that as opposed to something like GPL, which would like inhibit some of these bigger companies stealing quote unquote the work?
Right. The reason that we use a BSD license or just a permissive license in general is primarily because I've worked at so many companies where I was unable to use code because it was GPL. I was given some task. I found some nice GPL code to achieve what I was supposed to achieve, and then my manager would say, "You can't use that, Andreas. That's GPL." And I thought this is super tiresome. And it's happened so many times at so many companies. Companies are just scared of GPL. And I felt like I don't want to put out more GPL software in the world and just have a bunch of people frustrated that they can't use it. I just want to put out software that anybody can use for whatever they want. So that's kind of why I became a fan of permissive licenses and the BSD license. I was a very big GPL fanboy, I guess, when I was younger as a teenager. I put out GPL software in the past, but uh, you know, I got a bit jaded by the realities of legal paranoia around the GPL, I guess.
Before we take the next question, Andreas, do you want to maybe unshare screen? Because right now I think everyone's looking at a tiny picture of your face.
Oh, right. Sorry. Not new share. Wait, stop share. All right. Hello. Sorry about that.
Other questions for Andreas?
Sure. Hi, do you have any, thoughts on Apple starting to use Swift and WebKit to C++ interop?
I think that would be fantastic. When Swift came out, like a long time ago now, I was at Apple, and a lot of people on the WebKit team were super stoked, and they thought like, oh man, this is gonna be such a great fit for WebKit because look at all these things that are enforced in a much nicer way in Swift. It will make our code look better. But over time, they realized that you can't really interop between C++ and Swift. But now they're saying that Swift C++ interop is real. We've actually messed around with it a bunch because I kind of had the thought that it would be nice to be able to write some code in Swift because I'm a big fan of it. But we try to import our C++ code base into a Swift context, and the compiler just crashes. So it seems to be a little bit not ready. I think when Apple says that like, oh, you can now talk to C++ code in Swift, what they mean is that they support like maybe C++ 11, but our code base is C++ 20. So there's a ton of stuff that we use that just is not understood by the Swift compiler yet. But they are working on it, and I think when that happens for real, the WebKit team is probably going to be the first Apple team that just goes hard on adopting it.
Hey, I downloaded Ladybird this weekend and
Mhm.
I opened up my password manager and it's missing support for like an encryption algorithm. I'm just wondering, so I've taken a security class or two and they always say don't roll your own crypto. And so
Ah,
I'm curious who writes the like encryption algorithms for Ladybird.
we did. So yeah, we wrote it all ourselves. We implemented them from spec. So they're not super performant, all of them. There's like a lot of fancy stuff you can do. There's like fancy algorithms with SIMD. There are many CPUs have like dedicated instructions for crypto these days. And we don't really take advantage of any of that. So if you, well, as I mentioned several times, performance is a big issue, and encryption performance and decryption performance, you'll notice a lot if you profile our browser that it's just like spending a lot of time decrypting responses from web servers, and tons of room for improvement there. But yeah, I'm very aware that people say don't roll your own crypto, but then again, why not? It's fun. Um, I think you should roll your own everything. That's what we're doing. And, use at your own risk. I think there exists a future where maybe we will say, oh, you have the option of building Ladybird with like the system crypto library, like OpenSSL or whatever. But as it is today, like we really like having everything in our control. Like we control the whole stack, everything. And I mean, if we're running on Linux, we have to let them deal with the kernel, the device drivers, the windowing, and all that stuff. But if you run on Serenity OS, we control that stuff as well. So it's just this this vibe, this feeling of being able to poke around anywhere in the software stack is really satisfying. And it was the main thing that I took from Apple, because when I worked at Apple, you could always do that. Like if you had a problem with the kernel, you could go to the kernel building and get the kernel guy to explain to you why it doesn't work. And if you wanted to do like this cross-cutting vertical integration stuff, you could just get the right people from every team. They were all within like a 2-mile radius. You could put them in a room and figure out how to do stuff. And after leaving Apple, coming to the open source world, it was kind of sad how that is just not possible, because a typical Linux desktop is like written in 10 different languages in 50 different countries, and you have to get all those people to agree on something, and you just can't. That's very, very difficult. So that was one of the motivations for building Serenity OS the way that we do, is that we just control everything. And rolling our own crypto is just a side effect of that desire to just have everything under our control. It's not like we're not confidently saying like, oh, don't worry about crypto. I'm sure we don't have any bugs or timing attacks possible. I'm sure you can crack our crypto with some trivial side channel because we haven't audited it properly yet. But it's been super educational, I will say, to roll our own crypto, because we learned how it works and how it's put together. And we actually spoke with somebody a couple of months ago who was interested in doing a full audit of our crypto implementation. They were going to apply for like an EU grant, I think, and then they would get paid to audit the whole stack. So that was really nice, like a professional crypto auditing company. And I'm sure that they will find a million problems, and then we can fix them.
So you said you worked on the KDE, you helped worked on the KDE project, right?
Yeah, yeah, long time ago.
Other than KHTML and Conquer, have you worked on anything else when you were at KDE?
Oh yeah, yeah. I worked on everything. Um, if you go back in time, there used to be this thing called a KDE commit digest back in like 2005, 2006. I'm sure it's still online somewhere. and you can find they had this thing every week where they would be like, who's the most active KDE developer every week, and what did he work on? And I used to be like the top person because I was just fixing bugs in anything. I would sit on the bug tracker and just look at bugs that came in, try to fix them as fast as possible, because I just wanted to be the top bug fixer every week. I thought it was fun to win that game that I was really just playing with myself, I think, because nobody else was trying to be competitive. But yeah, so I worked on everything, but this was in KDE 3 days. So like we were putting out KDE 3.4, 3.5, I think was my last release. And KDE has this bad habit that it's built on top of the Qt framework. And whenever Qt puts out a new major release, they break the API and the ABI, and then KDE is like, oh, wow, a convenient excuse to rewrite everything. And then they go and do that. So when that happened and Qt 4 came out, and the KDE people said, oh, let's just drop everything and rewrite for KDE 4. And I got kind of disillusioned and stopped working on it.
This is more of an OS question, but I have some friends who work in Managarm, and I was wondering what you think about kind of their concept of kind of building more like OS infrastructure stuff like Lie, like the ACPI subsystem, mlibc, even their contributions to Lamine that kind of are usable for other OSs where they've kind of decoupled it from Managarm itself. And what do you think about doing that with Serenity OS, like decoupling some of the subsystems for other OSs?
I think that's something that we have been extremely bad at because we are very like siloed. As I said, we try to do everything ourselves. So we just don't end up building sort of reusable components. Our components are very interconnected with each other. They're like kind of tangled. We use the same data structures and libraries and stuff for everything. So there's a tremendous amount of code sharing and a lot of dependencies left and right that if you try to take any one piece and like lift it out and make it reusable by others, you end up having to rip like another 15, 20 components at the same time that you need to bring along. And then we actually do this on Linux for Ladybird. When you're building Ladybird on Linux or on Mac OS, we bring like a ton of Serenity OS components just so that we have that same environment on Linux. And it's a big chunky maintenance thing, and I think most other projects are not going to be interested in like that kind of dependency graph, like taking that on. If they're just looking, oh, we would just like the font rendering from Serenity OS, and turns out they also have to take our well, all kinds of stuff that comes along with font rendering, like 2D graphics, 3D graphics, XML parsing, whatever. They probably don't want that. But to answer your question about Managarm, I think that's cool that they're doing that, and I think it's more in the spirit of like traditional open source software where people try to put out like little things so that you can patchwork them together and build stuff. We are just a very different open source project. We are more like a re-implementation of Apple as an open source operating system. It's just me trying to recreate my Apple job, essentially. So I can continue working there, but I don't have to work at Apple. I can do all the same stuff for much less money.
Serenity OS has a bug bounty program. Do any of those past issues like stick out to you?
Oh shoot, I don't even remember the issues. Yes, we do have a bug bounty program. I've been steadily increasing the bounty payout, but nobody ever claims it. There was one guy who claimed it once, but then he made me donate to like a bird sanctuary or something.
Wow.
But I just thought that like you should have a bug bounty program. If you're a serious software project, you should say like, hey, if you find a way to break into our software, we'll pay for that. That's honest work. But yeah, it turns out like the people who find security bugs and make exploits, they just want the bragging rights. And like when I offer them money, they just say like, oh, no, I can't take that. But I think realistically, there's a threshold where like if I start to offer $1,000, probably they're gonna start. Somebody's gonna be interested. Um, but yeah, it's currently at $50 because early on I was a bit scared because I thought, what if somebody finds like 1,000 bugs and then I have to pay them a ton of money? So we started small, but it would be fun if somebody finally would claim it. But when it comes to like bugs standing out, some of them were really good. Like there was one guy who did a whole stack exploit. Like he broke in, like he would visit a website and he had an exploit for a JavaScript engine that turned into an exploit for the browser engine, which then turned into a kernel exploit. So he got full control of the kernel. So he wrote like the whole chain and wrote a blog post about it, which I think it's linked on our bug bounty page. And that was really cool. I was so excited that somebody had like, and then the people who do this, they're like professional security people. So they just do this for fun on the weekend. So it was really fun to see like a professional security guy do an exploit chain to break our browser and get kernel access. And some people thought I would be upset. They thought it like I would be, oh, he defeated my super security, but I just thought it was so cool.
I will note that claiming a bug bounty can also give you credit for the final project.
Sure. Yes.
Bucks, or whatever the bounty said. Other questions?
Okay, 2 questions. Are you hiring? If I got Shopify, would they pay me to work on Ladybird?
Okay, good questions. I don't currently have a budget to hire more staff, but I'm hoping to expand my budget. It's a whole process. I'm a software engineer. I'm not a fundraiser, but it's something that I've noticed that if I ask people for money, sometimes they say yes. So that's pretty cool. So I need to do more of that. And I do have some things like that queued up. So we'll see how that goes. But at present, I'm not hiring. And if you get a job at Shopify, I don't know that they would pay you regularly to work on Ladybird, but a couple of months ago, they had a sort of an internal hack week at Shopify. And some of the people working there came to our Discord and said, like, hey, I'm at Shopify and I want to do Ladybird for Hack Week. So I worked with a guy there and he made a bunch of improvements so that his pet Shopify store would work better. I think he had like a shoe store or something on Shopify. And we fixed a bunch of layout bugs for him. So it does happen, but I don't think they will pay you to work on it every day, sadly.
Questions? I'll butt in with a question. What part of the browser do you think has been kind of scariest for you? I know you mentioned on Twitter once the layout was really intimidating at one point. What do you think have been the hardest parts of the browser?
The hardest part of the browser? Oh, that's a good question. I don't know that any part is necessarily hard. The thing with browsers is that once you know how they're put together, you see that it's not super difficult work. It's just a lot of work. There's so much to do. And maybe like from my perspective, like the real challenge of building a competent browser is not any individual component, but like getting all the components to work well together and getting them to perform. Because that's kind of where we are right now, is that we have all these components that you can test individually and see that like, oh yeah, if you give it this HTML, it produces the right tree structure. If you give it this JavaScript, it prints the right result. But when you throw at it like a 200 megabyte website with tons of CSS and stuff, and then you want to see a visual result in like 1 second, turns out that's a really hard problem. And the existing browsers that you use every day, they have like a million optimizations and caches and all kinds of smart tricks to avoid work and sort of defer work or schedule work in smart ways. And we haven't done any of that yet. And none of that is in the spec. Like the spec tells you what should happen, but it doesn't say how to make it fast. And my job when I worked at Apple was on the performance team, the Safari performance team. So I'm like intimately familiar with how Safari gets fast, but it's going to take us a long time to sort of replicate all those techniques because they're very sophisticated techniques. But it's all so much fun for me. It really does feel like I've just recreated my Apple job, not just with the operating system, but also with browser performance. Because when I worked at Apple, I would go to work every day, profile Safari, and figure out how to make it faster. And now I'm almost at the point where that is exactly my job again, because the browser's getting competent, and now I just need to profile it every day and figure out how to make it faster. But yes,
Do you think that's the right pathway for Ladybird, doing compatibility first and then switching for performance? Or would like thinking about performance up front have some kind of
I think thinking about performance up front would have made it hard to get as far as we did, because it's very, very hard to stand up a browser in a vacuum. If you look at the specs, they are huge, and there's a ton of stuff that needs to work and work together before you see anything on screen. And even though we can sort of understand that, oh, it would be better if we would rasterize these things on the GPU and if we would do these things on multiple threads, if you're staring at a spec document that has like these 300 algorithms you need to implement, you're not really thinking like, oh, but how can I use the GPU to do this more efficiently? You're just thinking, how do I get it to do these 300 things? So I think it seems unrealistic that we would have been able to come up with sort of the optimal architecture from the beginning. But maybe we would have. Like at the same time, if I were to start over today, I would do it pretty differently. So maybe the real answer is that like I was just not knowledgeable enough. I didn't have a good enough understanding of how to do this when I started. And if I started today, I could do a better job. But that's like the most tempting thing always with any engineering project, that like, oh, if I just start over, it'll be much better. I'm sure you've all felt that way about something. But that's a trap.
On one of your recent videos, you talked a little bit about JIT versus byte population for JavaScript.
Mhm.
Can be more like thoughts on that, like on the performance side of Ladybird?
So I could not really hear the second part of that question. I was talking about bytecode versus JIT performance, but what was the question part?
Do you have any questions? Do you have any thoughts on how that impacts performance? And how that decision shakes out?
Oh, yes, I have lots of thoughts about that. So last year, one of the last things I worked on my YouTube channel was making a just-in-time compiler for JavaScript. And it did end up, like we ended up getting a lot of nice performance wins on benchmarks, like JavaScript benchmarks, where you just test throughput. But at the same time, it was introducing a lot of complexity in the code base. And it suddenly became like, if you wanted to make any kind of change to JavaScript, now you also have to take care of updating the JIT. And if you're updating the JIT, you have to know about like x86 assembly. And we were trying to add like ARM assembly for the new MacBooks. So like the amount of stuff that you had to know in order to effectively work on the JavaScript engine was growing very bloated, because now it wasn't enough to understand the JavaScript engine. You also had to be competent at assembly programming for at least one architecture. And I felt like that wasn't really worth the performance improvements we were getting, because while we did see improvements on benchmark scores, websites didn't load any faster. And the truth is, when you are loading websites, there's not that much JavaScript running for the most part. Websites are pretty good about not doing a bunch of stuff. There are exceptions, of course, But I think a good example of how it doesn't really matter is that if any of you have iPhones, you know, they have this feature nowadays called lockdown mode, which is like for politicians and celebrities and people who feel threatened or whatever. You can put it in lockdown mode. And in lockdown mode, it's like hardened security. And one of the things they turn off is JIT compilation. So I put my phone into lockdown mode and I've been browsing the web, mobile web, without a JIT compiler, and everything is fast. Like, and I thought for years that like there's no way it could be fast without a JIT compiler. But somehow it just works and you never really feel it. I think the one time I noticed that it was a bit slower was when I tried to load Google Maps. Then I noticed that, okay, this is taking a while. But like for the majority of browsing tasks, the JIT doesn't really matter. And I think what's happened here is that you have these companies like Apple and Google, and they have hundreds of people working on performance, and they have gone hard on performance marketing. So they all say like, oh, we are the fastest browser, we are the fastest JavaScript engine, blah, blah, blah. And at some point, it just stopped being about improving web performance for users in any way that matters. And it just became about like, let's be faster than the other guys. And I certainly know from working there that when I worked on Safari, my motivation was not let's make it better for users. What I was thinking was let's be faster than Google. Screw Google, like we can be faster. That's the thing that motivated us every day. And my manager actually had to tell me to consider the users. He was like, Andreas, you're just talking about Google, like you never talk about user performance. So I'm sure that the folks who are working on those things nowadays, at least some of them probably feel the same way I used to, that it's just a contest. So my thoughts on this today is that we've actually removed our JIT compiler from our JavaScript engine. We've gone back to bytecode. And I've spoken to, well, friends now, I guess, but the former lead architect of JavaScript Core at Apple and the former manager of the SpiderMonkey team at Mozilla. And I asked for their advice on what to do for JavaScript, and both of them told me, just don't build a JIT. Don't bother. It's not worth it. And I don't know that they would say this if they still work there, but now they do other stuff. And that was sort of their big main advice for me. Independently, they said, don't do it. It's not worth it. So I'm kind of running with that and not doing a JIT. And when we measure or profile our browser, we rarely, if ever, see JavaScript as the big problem. Really, the big problem is more like layout is slow, or drawing like tons of stacked gradients with blurs and shadows and stuff. That's slow. But JavaScript, not so much.
Just as a follow-on to that, Andreas, there's a bunch of sort of classic browser optimizations that, as far as I know, Ladybird doesn't implement. I'm thinking things like GPU rendering, multi-threading, invalidation, maybe retain display lists and retain surfaces and compositing. All are also pretty complicated. Are there any of those that, like right now, you think they're probably not worth it, or is it just like we haven't got them yet? Or is it that you have to?
I think those are all worth it, I think. And perhaps different levels of worth it, but invalidation is a very potent technique. The main way that we make progress on performance right now is really just finding ways to not do stuff. Like just adding heuristics or early returns where we can say like, oh, well, this couldn't possibly affect the outcome anyway. Let's just not do it. Or, hey, we can cache this expensive to compute thing. And I think invalidation is just part of that sort of category of things where you try to invalidate only what's necessary and only recompute what's necessary as late as possible, hopefully avoiding entirely. Really, all the things you mentioned are very interesting. I would say the only one of those that's hard is multi-threading. Like truly exploiting multi-threading in a browser engine is difficult because well, because of JavaScript being a single-threaded language, that makes it hard. You have a lot of synchronization points where like stuff is expected to happen in a certain way. But yeah, all of those things are things that we should do and things that we will do. And I'm glad that you call them classic browser optimizations. That's such a nice way of thinking about it.
Okay,
And
let me
if anybody,
question though. What about something crazier like Safari? I don't know if this is your time or before your time, or after your time, has something called CSS JIT, where they
Mhm.
JIT file CSS selectors. How do you feel about that? Worth it? Not worth it? It's pretty good. It's fast.
right? Yeah, my friend Benjamin wrote that. So the CSS JIT ended up being it's one of those things where we were very proud of it at Apple at the time because nobody else has a CSS JIT. Look how much faster we can run those selectors. And we blogged about it and we bragged about it. I think it even was in the WWC keynote that year that we put it out. But the same thing happened at least Google. They also built a CSS JIT, but they threw theirs away because they said, yeah, this makes the WebKit benchmark faster. That the benchmark that Apple made to show off, but it has no real measurable impact on any of the websites we're tracking. So it was on the public mailing list that Google has, and they just said like, we did it, not worth it, throwing it away. And uh, full disclosure, I wrote a CSS JIT last year because I thought, hey, that would be fun. And I ended up throwing it away too because it's like, yes, and now I have this complicated thing that generates assembly to run CSS selectors. But what have I really achieved? I can run that cool benchmark that Benjamin made, and it's really fast, but it doesn't show up in any profile. So do I really want to force everybody to learn how this thing works? Or can we have like the nice, simple recursive selector matcher that you can sit down and understand in 5 minutes?
Sure. This might be an uninformed question, but why not just use the key profiles as your benchmarks instead?
Use the what profiles? Sorry.
The key profiles, the important profiles for websites that you're following.
Right. So I think there are just so many different aspects of performance with browsers, and different websites just have totally different performance problems. So when I load the university website, the main problem is network performance. It's not a problem that we can't run the JavaScript. It's not a problem that we can't decompress the images or decode the JPEGs or whatever. It's just networking, and we're doing stupid stuff with networking. I think we're loading like 100 fonts that don't end up being used, and we just sit there and download them anyway because we're not smart enough. Whereas some other website, like Google Maps, for example, they do a ton of path rendering, like path rasterization. So that's like a totally different performance problem. So you could probably create a set of profiles for all kinds of things like this, but it isn't really something anybody has succeeded in doing. The closest thing to a proper web benchmark that exists is this thing called speedometer, which it used to be an Apple thing, but now it's other browsers have joined in, so they're all doing it together. And speedometer is sort of an automated web app that just you run it, and then it simulates a to-do list and some project management UI and an email client, I think, and a bunch of things. And it's just like it's a fake web app that runs itself and clicks around and does stuff. And that seems to be the closest approximation to like real website performance, real responsiveness, and so on. And that's absolutely something that we do want to target. I would say that's like the only benchmark that we should really care about is that one. And all the other ones we can care about for fun, but that one we should take seriously.
Your thoughts on like WebAssembly and like potentially using WebAssembly in the OS for like user space stuff?
WebAssembly, yeah, sure. I think it's very cool, and I love that I can run Photoshop in the browser nowadays. And I think it's one of the things that makes my philosophy about JIT compilers a little bit difficult because Since we don't have a JIT compiler, we can say like, oh, we can disable the ability to generate code at runtime. And it gives us the security benefit of disabling executable pages. But then there's WebAssembly, and WebAssembly is legitimately useful, but it also requires that you're able to generate code at runtime because you really want to JIT compile it. So it will force us to look for a security model where we can download WebAssembly code and compile it to something, but at the same time not shoot ourselves in the foot and have a huge security problem because of executable memory. And it's unclear to me how to achieve that in a perfect way. But I think it's a fantastic thing. And what I really like about it is that for Serenity OS, nobody's ever going to write device drivers for Serenity OS. It's just not happening, right? Like nobody's writing a webcam driver and shipping it for Serenity OS other than us ourselves. But companies are not going to do that. But if in the future somehow there exists a driver model where you can like make a WebAssembly driver for something, that could potentially be a way for us to use other hardware on Serenity OS without having to copy Linux drivers or like make our own drivers. And that I kind of like that. But our WebAssembly implementation, by the way, is not super mature. There's a WASM test suite, and I think we don't even pass half of it. So tons of stuff there to work on if everybody's interested in WebAssembly. Tons of stuff everywhere to work on.
Jump in while people think. So you talked a bunch about complexity and, things that aren't worth it. If you could like remove some stuff from the web to make it simple, right? So I'm talking about web features that we're all going to collectively forget about. Maybe bigger than the marquee tech, but it could be small, it could be big. Would you pick anything? Like, would you say like just don't have a val in JavaScript, or like no stacking context in the land engine or something like that?
Sure. Yeah, I would probably take out eval on the first day that you gave me this power. Eval is it's just a pain to deal with. The fact that you can throw a string at the JavaScript engine and say like, hey, compile and run this in the current context. Have fun. That it creates a lot of problems for JavaScript engines because you have to be resilient to sort of the world disappearing under you suddenly, or assumptions don't hold because somebody evaled something. Somebody like created a new variable in the current context, even though it's not there when you look at the code, it was just inserted by eval. So I would love to get rid of that if I could. But I think in general, like it's fun to dream about these things, but we're kind of stuck with the web platform as it is. So I find it more constructive to just accept it and embrace the warts. That's something that you notice when you're working on a browser is that while people on social media, they talk about all the latest features and using like the latest frameworks and hosting their websites on Vercel and whatever. And then you go out there and you look at real websites and they're using like JavaScript frameworks from 15 years ago. And they don't care, they don't update, and we have to run this code. And it's like, it's a different reality out there when you are a browser and you have to tolerate all this stuff. So I've kind of just tried to take this Zen approach of just accepting the web platform as it is and not try to change it. But yeah, it is fun to think about, and I would love to not have to deal with eval. I will agree with that.
How do you go about learning the parts of the web platform that you don't know? Like, it has to be a lot, even now. So like, what if you're implementing some new feature, I don't know, imagine you decided to implement WebRTC, which maybe you don't know anything about. Maybe you do, I don't know. How would you go about, like, what's your approach to like learning about it?
Well, usually the way I go about all development is I just open a website that uses the thing that I want to implement, and then I try to run it and see what fails. Usually we will print out a fix me, or we will throw a JavaScript exception or something, and then just start from there. I'm very like iterative exploration programming style. And I come from a background in emulation. So I used to write emulators for PCs and video game systems and stuff like that. So I really like that feeling when you're like implementing a game console and then you just put a ROM into your emulator and then you see what happens. Uh, and then like you discover that, oh, this instruction is not implemented correctly in my CPU. So you fix the instruction and then suddenly like a sprite appears on screen and you can see Super Mario or whatever. And that's so sweet. And I try to work on browsers the same way. So I just like load in the ROM, which is the website, and then see what doesn't work, and then see what I need to do to get Mario to show up. So I would probably approach WebRTC in the same way. Like I guess maybe download a simple WebRTC demo app. I'm sure there are 1,000 of those on GitHub. Download one and see what it tries to do, and then just implement the APIs that it's trying to use.
This is more of a C++ question. Do you have any thoughts on the reflection TS and the paper proposals that are conflicting over pattern matching currently?
I do not have thoughts on that. I don't follow that as closely as perhaps I should, because I would love to have reflection, but after being a C++ developer for the last 20 years, I stopped thinking that the committee was going to hurry up, and now I just accept that they put out stuff when they're ready. And I get things when I get things. But yeah, I've never been involved in the standards process, so I can't really comment.
Okay, so we're about at the end of our time. I know that people are starting to leave because they have to run to their next class. So Andreas, if you have any final thoughts, and then we'll end the lecture.
Sure. No, thank you so much for inviting me. And if anybody's interested in working on Ladybird, let me tell you, we have so much low-hanging fruits. And there's tons of entry points where you can go and contribute to like important infrastructure and APIs in a new browser engine. And you don't have to be a superstar C++ developer. We have people who learn C++ coming from like a Python background or no background. They learn C++ while working on our stuff. So it's a very helpful community where you can definitely do more advanced browser development. So if anybody's interested in that, come hang out on our Discord and try some websites. I'm positive you'll find bugs. And of course, the bug I demonstrated fixing today, I had investigated that yesterday, so I knew what the bug was going to be. It seemed a little bit risky to just not know what the bug was before starting a demo of fixing it. But on my YouTube channel, I do that. I just go out and fix random stuff. Sometimes it takes 30 minutes, sometimes it takes 3 hours. But I didn't want to do that to you. So I guess I would say thank you all for coming to this lecture and for asking so many questions. And I hope that I will see some of you, at least in our project. And I wish you the best of luck with your Ladybird related projects.
All right, let's give Andreas a round of applause. Joining us, Chris.
Thank you for having me.
All right, folks. So I will see you all, those of you who are in the class. I'll see you on Thursday, where we're going to start maybe a Ladybird related project.